Okay, dear students, in continuation with this earlier class, I am going to discuss about the friction. This part is very important for you because some numericals will come in your entrance exam. So, when we are talking about the friction, you just say friction. So, what is the meaning of friction? So, what is the definition of friction? So, how the friction will develop? Suppose if we consider this is a kind of table, this is a kind of table. So, on the table, one object is placed. This is a kind of object. So, when object is placed on the table, at the time you remember there is a kind of friction develop in between the table and the surface of the object. So here contact body is there. One is here the surface of the table and other is surface of the object. So there is a friction in between this. Now thing is that what is the definition of friction? Friction basically when one object is sliding of the over the other body or sliding on the other body, then we can say this is a kind of friction. Friction means it is possible due to the supply of force. So friction basically there are different types of friction, rolling friction, then dynamic friction, static frictions. So static friction basically when both the object, that means suppose if we consider this object is at rest and the table is also at rest, so the friction developed in between the two raised body, it is called static friction. For example, dynamic friction or rolling friction, for example, you can consider ball. So when ball is throwing into upward direction or throwing into horizontal direction, then the ball will move. So during the motion, rolling friction will develop. So there are different types of frictions. Basically, it is related with the situations. Now see, I have considered one diagram. You can see this is a table and this is a kind of object. Now you just see here, so one force is applied on the object. This is a kind of object and here a force is applied on the object. So when a force is applied on the object, then due to the force a kind of opposite frictional force is developed in between the two surfaces, surface of table and surface of the object. So this force, it is called Fk, or normally we can say force F. So in this case, now see, when a force is acting on an object and due to this applied force, a frictional force is developed on the body. So the weight of the body acting downward, this is called N. So you remember in this case, N means normal force. This is called normal force. This is called normal force. And here F is a applied force. Applied force. So dear students, you remember, you should know the physical significance of the particular force, because you have seen here F is a applied force, this is a normal force, this is a frictional force. So you must know the physical significance of the particular forces. So here F, this is called your frictional force. Frictional force. So you can see here, this is a normal force, applied force and frictional force. This is a normal force. Normal force means this force particularly upward and it is acting downward force. This is a normal force. Now you can see basically the force of friction or friction always depend upon the weight of the object. If the object weight is more, then friction will be more. If the weight of the object is less, friction will be less. So that is why you remember the frictional force, that means the frictional force, therefore you can write frictional force F is directly proportional to the normal force. You remember, because if the weight of the object is more, friction will be more. That is why this type of frictional force will be developed after using the weight of the object. So therefore we can write F is equal to mu n. Here mu is a coefficient of friction, you remember. So coefficient friction, it is basically represented by mu. So mu F is equal to mu n. Now you remember here this is a kind of formula, or mu is equal to F by N. F by N. So how we can define the coefficient of friction? This is called coefficient of friction. Coefficient of friction means it is the ratio of frictional force to the normal force. It is defined as frictional force to the normal force. So this mu is equal to small f divided by n. Here coefficient of friction. So coefficient of friction basically represented by mu. Mu is equal to F by N. So this is called coefficient of friction. So you remember from the given relation, it is clear that the coefficient of friction has no unit, because here there is a force. Force is Newton. Here also force Newton. So Newton cancel with each other. So that is why coefficient of friction has no unit. So sometimes in entrance exam, some question is given like this: which of the following quantities have no any unit? It has no unit. You can see the following quantities may be given 3, 4, 5 like this, and single quantity also may be given. So we have to know about the friction. This is called coefficient of friction, and this coefficient of friction has no unit, you remember. Now see here, this is a frictional force, this is a normal force. Normal force means mg, and this is called your frictional force F. So you remember in this case, what is the unit of coefficient of friction? Coefficient of friction has no unit, so you remember. Now there is a kind of relation between the angle of friction and coefficient of friction. So relation between angle of friction and coefficient of friction. Okay, so relation between angle of friction and coefficient of friction. So what is the relation? You remember there is a one relation, mu is equal to tan theta. Mu is equal to tan theta. So where you will get the tan theta? So you remember in this diagram you can see this is the angle. This is the angle. This angle basically it is called angle of friction. This theta, and where you remember where theta is the angle of friction. Theta is the angle of friction. So in this case, theta is the angle of friction. So mu is equal to tan theta. Mu is a coefficient of friction, and theta angle of friction. So sometimes some question may be given related with the friction. That means mu coefficient of friction would be given, and you have to calculate the value of angle of friction. Now another things. So this is the friction. This is the idea of friction. So basically, in case of friction, you remember this is called angle of friction, and this is called coefficient of friction. Now, in case of angle inclined plane, this is a normal, and for inclined plane, what will be the angle of repose? Angle of repose. So what is the meaning of angle of repose? You can see here angle of repose. Now see angle of repose. Angle of repose. That means alpha. This is called angle of repose. Now see for inclined plane, if you consider this is a kind of inclined plane, inclined surface. So one object is here. This is a kind of object. This is a kind of object. So here it will be mg, and here mg cos alpha, and here mg sin alpha. So this alpha is called it is called your angle of repose. This alpha, it is called angle of repose. That means here the one force is resolved into three components. One is mg sin alpha, another is mg cos alpha, another is mg. So there are three forces will act during the inclined motion. So this is a one formula, angle of repose. You remember So angle of repose, basically you can see alpha. Alpha is the angle of repose. In case of angle of repose, you remember the components forces are there. One is mg, mg sin alpha, mg cos alpha. So these diagrams, sometimes it is also we can write like this. It can be like this. It can be like this. Object is here. Object is here. And it may be like this. Object will be here. So here if we consider n1, if we consider n2, so here it may be like this, it may be like this. That means it will be mg sin alpha, here it will be mg cos alpha, here mg, here alpha, and here also alpha, mg and mg cos alpha. So this diagram we can show like this also. So you remember the basic difference between the angle of friction and angle of repose and coefficient of friction. And basically the friction of an object always depends upon the weight of the object, you remember. That means if the weight of the object is more, that means force will act on the surface will be more, then the friction will be more. For example, one heavy object placed on a table and one light object like a feather, after keeping the feather on the table, then you will get less amount of frictional force developed in between the two surfaces. So this is the idea. That means you remember, in case of angle of friction, coefficient of friction and angle of repose, you must know. Now you remember how we can calculate the value of coefficient of friction, value of angle of friction, value of angle of friction, value of angle of repose. So now I am going to discuss part by part. Now thing is that first, this is very important topic, friction. Number one, you can see, you must know free body diagram. This is called free body diagram. Free body diagram. So free body diagram, FBD, free body diagram. So how we can write the diagram in free way? For example, you can see, this is a one example. One object is here. So if we consider two object is here like this. If we consider two object is here. Okay. Now here M1 and here M2, two object is here. Suppose a applied force F is acting on the object of mass M1. So you remember, when force is acting on the mass M1, the force direction is forward direction. So acceleration of the body will also forward direction. That means F is acting forward direction, so acceleration will also forward direction. So in this case, you remember, we have to make the free body diagram. So what is the formula? What is the process? How we can make it free? So solution, you remember. So initially you can see this is the diagram. So this is the diagram. This is the diagram. This is the diagram is given to you. This diagram is given to you. So in this case, you can see force is applied F. This is mass M1 and this body having mass M2. So due to this force, the body will move into forward direction. So acceleration will along forward direction. Okay, now see here, when the force is acting on the body of mass M1, there is a kind of equal and opposite forces will develop according to Newton's third law. So according to Newton's third law, this force will develop. So we can write separately the forces. So this force we can write like this. You can see this is M1 and this is M2. So when force is applied on the body F, here you see the opposite force I consider. Suppose the opposite force, it is in between this one. So if you consider F1, so when the force is acting forward direction, at the same time the amount of force, that means opposite direction. So here you can see this will be force acting forward direction, so opposite direction will be like this according to Newton's third law. And here you can see the force will be in this way, that means F1 force will be like this. So that is why you remember in this case how we can write in free body diagram. So you remember in this case the acceleration is into forward direction. So therefore F, for the first diagram we can write F, force is going forward direction and it is backward direction. That is why F minus F is equal to M1E. This is a kind of formula for the first body. Similarly, for the second body we can write F1 is equal to M2E. You remember. So this is called free body diagram. That means diagram is connected, both the diagram is connected, and this connected diagram we can separate, make it separate, and particularly you remember we can make it free with each other. So that is why this diagram is converted into free diagram. So that is why this is called free body diagram. And you remember this is the formula for free body diagram. You remember this is the formula for free body diagram. So free body diagram, number one, you can see for two bodies, for two bodies. So now see, in case of for three bodies diagram, so what will be the free body diagram? You can see very simple. You have to remember the basic logic of the given diagram. So suppose for three bodies, number two, for three bodies, so this is the diagram. You can see like this. So one body is here, another body is here, and in this way another body is here. So I consider three diagram here. So this diagram is M1 and this diagram of mass M2 and here M3. Now students, you remember in case of two body diagram, so in case of three body diagram, when force is applied, that means here force F is applied on the body. So due to the force, you remember the motion of all three connected bodies along forward direction. That means acceleration will be forward direction. So in this case, free body diagram, that means now we are going to find the opposite force. That means according to Newton's third law, every action and opposite reaction is there. So equal forces and equal and opposite forces. So according to free body diagram, we will make three diagram here. You can see three diagram. So for the first diagram, you can see here M1. For the second diagram, mass is different, like the shape of the body is different, M2. And third diagram, it will be like this. It will be M3. Now, dear students, how we can make it free? Now you see, when the force is acting, due to the force, this is a applied force F, and due to the force there is a kind of opposite force F1, and here also F1 force will develop in between the two bodies. In this case, you can see here also it will be force F2, here it will be force F2. So this is the free body diagram. So now what will be the formula for each cases? So for the first body, you can see when F is acting forward direction, the frictional force is opposite direction. So that is why we can write F minus F1 is equal to M1E. So this is the formula for the first body. And similarly, in case of second body, you can see the F1 force acting forward direction and F2 force acting backward direction. So in this case, the force F1 minus F2 will be M2E. And in this case, you see only one force is there. That is why we can write F3 is equal to M3 into A. So this is the formula for three bodies, free body diagram. So students, it is very important how to write the formula. You have to generalize and you have to know the physical significance of all the terms used in the given formula. Now see here, I have used capital F. Capital F will be the applied force, and F1 will be the force between the two bodies M1 and M2. And here you can see F2. F2 means these forces here like this, equal and opposite forces in between the two bodies. So that is why we can write this formula in this way. So you remember free body diagram. This is called free body diagram. So using this same conception, we can also write some numericals, some free body diagram, some problem is there. We can use suppose connected bodies. For example, in case of connected bodies, so you can write free body diagram for connected bodies. This is also connected, but with the help of thread, when it is connected, then it is called connected bodies. So again you can see there is a two bodies. I consider three bodies. Here three bodies I consider. This is not connected but connected with a thread like this. So in this case you can see when force is acting, suppose I am giving the force opposite direction, that means it is like this, it is like this in this way. So here it is going backward direction, so force will forward direction, it will be backward direction. So in this case you can see this is a backward direction, it will be forward direction. So now it will be backward direction. So that is why in this case you remember when the bodies are connected with each other, touches with each other, at the time we have to consider F1, F2 like this. But if the body is connected with a thread, at the time there will be tension. That means this tension can be represented like this, T1 and here T2. So this is the body is M1 and here the body is M2 and here body is M3 like this. So in this case you can see for free body diagram we can write like this in this way. This free body diagram we can write like this. You can see the force is acting forward backward direction F. So at the same time it is opposite direction, and here also like this opposite direction, and here T2, so it will be T2 like this. So the body of mass M3, M2 and here M1. So what is the formula in this case? You remember for the first case the force is acting backward, so F, and here forward, so F minus T1 is equal to M1E. Here in this case acceleration will be opposite direction. Here you see I have considered here force is acting forward direction, therefore acceleration will be forward direction. But in this diagram you can see the force is acting opposite direction, therefore acceleration also opposite direction. So that is why you remember for the first diagram, you remember this is a applied force. So this applied force opposite direction with each other. So that is why we can write F minus T1 is equal to M1 A1. Now you can see for the second diagram, we can write here T1 minus T2 is equal to M2A. So this is the formula for first diagram, and this is the formula for second diagram. And for third diagram you remember T2 is equal to M3A. This is the third diagram. So you remember this is the formula. So in this way, depending upon the body, when the two or more bodies are connected with each other, depending upon the connection, we can consider the formula. So we can justify the formula, we can write the formula in this way. So and from the given formula, we can easily solve the problem. So another things. So this is the connected bodies. So connected bodies, you remember, it may be with the help of thread, it may be body directly connected with each other. If you see both the diagrams, you can see then there is a thread in between, but there is no thread directly connected with each other. So this is contact body and this is connected body. Now see one more conception. So this is the conception of free body diagram. Next you can see hang body. That means hang body. So in case of hang body, you can see number 3. So there is a two condition. So when the system is at rest, when the system is at rest, then you remember this is a system is at rest. One body is here, another body is here, another body is here, like this. So in this case, you remember, if the system, this is M1, this is M2, this is M3. So when the system is at rest, then you remember here it will be T1, here it will be T2, here it will be T3. So dear students, you always remember the formula always depends upon the system. If the system is in at rest, then this formula will come like this. T1 is equal to M1 plus M2 plus M3 into, here it will be Z. Here it will be Z. But you can see T2, it will be M2 plus M3 into Z. And here T3 is equal to M3 into Z. So from the given diagram, it is clear that the tension force for all the three cases is maximum in case of T1 or Z. So T1 it is given M1 plus M2 plus M3 into Z, and T2 it is given M2 plus M3 into Z, and T3 it is given M3 into Z. So maximum tension in which part the maximum tension will develop, whether T1, T2 or T3 from the arrangement. So it is clear that from the given arrangement, the maximum tension will be in T1. Why? Because here all the three bodies giving the weight on that. So that is why the maximum tension will be generated in case of T1. Next, you see, what is the, when the system is in motion. So earlier case it was at rest position, but the same diagram, when the system is in motion. So number 4, when the system is in motion. When the system is in motion. So in this case, you remember, when the system is in motion, the diagram will be like this also only. Like this only. So here it will be M1, it will be M2, it will be M3, it will be T1, it will be T2, it will be T3. So in this case, you can see, according to our heading here given, when the system is in motion, at the time the formula will be T1 is equal to M1 plus M2 plus M3 into Z plus E. So when the system is in motion, at the time we have to use Z plus A. Again, T2 will be like this, M2 plus M3 into Z plus E. Again, T3 is equal to T3 will be M3 into Z plus E, Z plus E. So this is the basic idea, you remember. This is the basic idea of the formula, how to find the tension T1 and T2. So from the given diagram, only one thing to remember here, if the system is at rest, then only acceleration due to gravity will be multiplied with the given formula. But in case of system in motion, it is given, then acceleration, this acceleration will be added with the acceleration due to gravity. You remember what is the basic difference between small g and capital Z? So you can see, small g means acceleration due to gravity, and here A means acceleration of the particle along horizontal direction. If the particle is going forward direction and coming backward direction, at that time you can consider this is a linear acceleration. But in case of small g, you always remember this is a acceleration due to gravity. That means it is going upward direction or vertically downward direction. At the time we can consider this is a kind of acceleration due to gravity. So in this case, In this case, this is the difference part. Only you have to remember, in case of rest, acceleration will not be added, and in case of motional system, if the system is in motion, then we have to consider this is in acceleration due to gravity will be added with acceleration, linear acceleration. So students, you always remember this is the formula. Okay, thank you.